Hey everyone! Today we're diving into one of the most obscure and fascinating chapters in early aviation history, an aircraft that almost nobody remembers, a design that looked more like something from the future than the 1930s, and a group of engineers who tried to solve problems that modern aircraft only solved decades later. This is the story of the Soviet Bureau of Special Constructions, known simply as BOK, and the radical flying wing that emerged from it. The central figure in this story is Vladimir Antonovich Chizhevsky. Chizhevsky was not a celebrity designer like Tupolev or Ilyushin. He did not build famous bombers or fighters. He did not appear in propaganda posters. But inside Soviet aviation circles, he was known as something much more dangerous, a man who thought too far ahead. He was obsessed with theory, with airflow, with stability, with what aircraft could become, not what they were at the moment. In 1930, Chizhevsky was placed in charge of a brand new research organization, the Bureau of Special Constructions. BOK was not a normal design bureau. It had no mass production targets, no strict military deadlines, no pressure to build combat aircraft. Instead, it existed for one reason: to explore the limits of aviation itself. BOK engineers worked on high-altitude aircraft, pressurized cabins, experimental layouts, unconventional aerodynamics. In many ways, BOK was closer to a scientific laboratory than a factory. And because of that, BOK became the perfect place for radical ideas. The early 1930s were a strange moment in aviation. Aircraft technology had advanced enough to make bold experiments possible, but it was still primitive enough that nobody truly knew the correct answers. Engineers around the world were asking, should aircraft be faster, or more efficient, or more stable, or capable of flying higher and farther? No one had yet discovered the dominant design philosophy, so everyone experimented. During this period, designers in many countries became fascinated by tailless aircraft. The logic seemed simple. Why carry a fuselage and tail if the wing itself can lift everything? A flying wing promised lower drag, higher efficiency, longer range, less structural weight. On paper, it looked perfect, but in reality, it was one of the hardest problems in aerodynamics. Long before BOK, the idea already existed. In 1910, British officer John William Dunn built one of the first true flying wings. His aircraft had swept wings, no tail, natural self-stability, and unbelievably, it actually worked. Dunn's aircraft could fly hands-off. It corrected itself in the air. It resisted stalls. This shocked the aviation world. For a brief moment, it looked like flying wings were the future. But then, reality returned. Most flying wings had severe problems. They were unstable in pitch. They had poor yaw control. They required constant pilot attention. Small mistakes caused crashes. Without modern computers, controlling a flying wing was almost impossible. And so, for decades, the concept remained a dream. Unlike many Western programs, the Soviet system allowed long-term experimental research without immediate commercial pressure. Chizhevsky believed, if we don't solve flying wings now, someone else will in the future. So BOK began working on several experimental designs, 7 aircraft in total, but only one of them fully embraced the flying wing concept. BOK-5 was not designed as a fighter, a bomber, or a transport. It was designed as a pure experiment. Its only purpose was to answer one question: can a flying wing be made stable and practical without electronic systems? Chizhevsky's approach was radically different from most designers. He did not try to force stability with large control surfaces. Instead, he focused on geometry, mass distribution, aerodynamic balance. The idea was that if the geometry was correct, the aircraft would naturally behave correctly.
This is the same philosophy used today in stealth aircraft, modern drones, high-efficiency gliders. But in the 1930s, this was revolutionary. Without a tail, the wing must handle everything: lift, stability, control, balance. Every small error in design multiplies in flight, creates unpredictable behavior. BOK-5 required extreme mathematical precision, careful wind tunnel testing, and constant redesign. It was one of the most technically demanding projects of its era. Modern flying wings rely on digital flight computers, constant sensor feedback, automatic correction. BOK-5 had none of that. It relied entirely on mechanical systems, human reflexes, and aerodynamic theory. It was trying to solve 21st century problems with 1930s technology. BOK produced no famous combat aircraft, no wartime victories, no propaganda icons, and history tends to forget experiments that don't produce weapons. But the ideas from BOK quietly survived. They reappeared later in German Horten flying wings, Northrop's UYB-49, the B-2 Spirit, modern stealth drones. BOK didn't fail. It was simply too early. The aircraft itself. So what exactly was BOK-5? At first glance, it didn't look like an aircraft at all. There was no long fuselage, no tail boom, no vertical stabilizer. Just a thick, swept wing with a small cockpit embedded inside. Everything, pilot, engine, fuel, controls, was hidden inside the wing itself. It was quite literally a flying slab of aerodynamics. Chizhevsky did not want BOK-5 to behave like a normal aircraft. He wanted it to behave like a natural system, like a glider, like a bird, like something that wanted to fly instead of being forced into the air. The entire structure was built around one idea: stability must come from shape, not from force. This meant no oversized tail surfaces, no artificial stability tricks, no brute force control. If the geometry was wrong, the aircraft would fail. There was no safety net. The cockpit of BOK-5 was small and deeply embedded into the wing. From the pilot's perspective, visibility was strange. There was no long nose, no tail behind, only the wing stretching out left and right. Pilots described it as sitting inside a moving airfoil. Everything felt different: control response, sense of speed, perception of altitude. Even experienced pilots needed time to adapt. Controlling BOK-5 was one of its biggest challenges. Without a tail, all control had to come from the wing itself. This was achieved using elevons, combined elevator and aileron surfaces, carefully tuned control linkages, and extremely sensitive balancing. Every small input had a noticeable effect. There was no margin for error. When BOK-5 finally flew, it did not crash, which in itself was already a success. It took off, it climbed, it maintained flight. The basic concept worked, but almost immediately problems appeared. The biggest issue was longitudinal stability. In simple terms, the aircraft struggled to maintain stable pitch. It constantly tried to nose up, nose down, overcorrect itself. Pilots reported that the aircraft felt nervous, not uncontrollable, but always on edge. Another problem was yaw stability. Without a vertical tail, BOK-5 had difficulty resisting sideways motion. In turbulent air, it became unpredictable. These problems were not surprising. Every flying wing suffered from the same issues. Modern flying wings solve them with computers, gyroscopes, real-time correction. BOK-5 had none of that. It relied purely on airflow, mechanical balance, and pilot skill. It was fighting physics with mathematics alone. BOK-5 was not a fast aircraft. It was never meant to be. Its engine was modest, its speed was limited,
Its range was unremarkable, because performance was never the goal, knowledge was. From a military perspective, yes, it was never useful as a weapon. It had no combat role, it offered no immediate advantage. But from a scientific perspective, absolutely not. BOK-5 proved that a flying wing could take off safely, could be piloted by humans, could be controlled without a tail, could survive real flight conditions. That alone was a breakthrough. The late 1930s changed everything. War was coming, budgets shifted, experimental research lost priority. The Soviet Union needed fighters, bombers, transports, not philosophical flying wings. BOK was gradually dissolved, its engineers reassigned, its experiments archived, and BOK-5 quietly disappeared from history. Decades later, the world returned to the same idea, but this time with digital computers, fly-by-wire, stability augmentation, and suddenly flying wings worked perfectly. The B-2 Spirit, stealth drones, modern UAVs, all of them rely on the same concept, just with better tools. BOK-5 was not a dead end, it was a preview of the future, a message sent forward in time. It showed what was possible, even if technology was not ready yet. BOK-5 never flew in war, it never carried bombs, it never became famous.